Hey guys. Okay, lesson 3 this morning, or this afternoon. Okay, guys, this is lesson 3, chemical tests for cations AS. Okay, so this one's actually a little bit more tricky. Just things are starting to become a little bit more convoluted or a little bit more complicated. So bear with me. This isn't going to be a faultless video, and I do not pretend to be flawless. I'll do my very best to try and make this as concise as I can. Let's go straight into it, guys. I'm gonna waste your time. Entire screen. Let's get going. Okay, right. Okay, hide. All right. So we're on to lesson 3. This is lesson 3, cations. Okay, this is a bit more tricky, this one, and I've actually started this just because this is just requires a little bit more of a conversation, and there are so many ins and outs of all of these things that it's very easy to get lost. So bear with me. This will actually make a lot more sense because at the end of this sequence, this will be my last one that I do today. I'll do anions tomorrow or the next day, maybe Monday. But once I get to the end of all these videos, once I get to lesson 4, anions, what I will then do is I will do a lesson going through as many paper 3 questions at AS, looking at the example questions where everything that we have done will tie together and hopefully make a bit more sense. Okay, so I need you to know the cations that we are testing for. Not so much the test, although there are different tests. So I need to know the cations that we're testing for. I need you to know the observations, and I need you to be able to write ionic equations for each of the processes. I'm just going to quickly just check that the video is running okay. I know this is really irritating that I have to keep doing this. Yay, it's all going well. Cool, I'll kill that off now. Head back to here. Okay, got rid of my face staring at the ceiling. Nice. Evans, sup, Evans? Evans, this, hey, Mix21, thanks for coming along. Nice to see you again, Evans. Thanks for coming along. Stay with me. There's a lot of this stuff which is useful for you. And obviously, like as I said, lots of this ties back to GCSE and then rolls straight into AS. By the way, Evans, if you're wondering why I'm doing this, it's me, Anna, 8DR. Hey, Anna, thanks for coming along. I've also got, hello, Mr. Duncan. I've got a feeling this might be another one of my year 8s by any chance. Hi, Anna, thanks for joining me. Brawl reposter, okay. Thanks for coming along, guys. It's nice for you to be here and give me a bit of support. It's Vettel. Nice one. Thanks for coming along, Vettel, one of my year 8 students. Okay, folks. So this is chemical tests that are done at A-level. So obviously, Anna, Vettel, this is definitely going to be something that you'll do at GCSE. And as I said, this goes a little bit further, but you're happy to stick around if you fancy just having a bit of banter. I've got Senna here as well. Thanks for coming along, Senna. These are all my students from my school. I'm so glad to see you guys. Thanks for coming along. Okay, guys, so cation testing. So I think the first thing, so since I've got some of my year 8 students here, I need to try and add a little more detail here to try and explain to them about the context of what this chemical tests is all about. So cations. So in certain things like household salt, sodium chloride. Sodium chloride is household salt, otherwise known as sodium chloride. It's nice to write down the name. That is a really fat pen. I'm zoomed right in. Sodium chloride is actually made of 2 parts. It's made from Na plus cations. Now, cations are positive ions. And it is also made from chloride anions. It's nice to see the change in the name. And anions are negative ions. So it's nice to kind of add a little bit of that detail in, even though I know that perhaps from the A-level standpoint, you guys are already on this, but it's nice to put this into the context of younger students. So we've got our cations, which are positive, and our anions, which are negative. This lesson is focusing specifically on the detection of cations. Okay, so one of the nice things I think it is to do at certain stages is to kind of give you an overall picture of the cations we need to detect. And at A-level, by the way, I will tell you, by the way, that there are other cations which can make an appearance from GCSE. such as zinc 2+ and calcium 2+, oh no, calcium, and aluminium 3+. They can make an appearance, but these are the 10 that are most commonly seen. So what I'm going to do is I'm just using this video to be able to give the most common tests that we're going to see on papers. As I said, this will be super useful once we get to lesson number 5, where I start looking at exam style questions from A-level papers. So I need you to be able to do all these things, know the cations to test for, 10 of them, know the observations, and write ionic equations. Okay, so cations to test for. Now, what I've also done is I've then boxed off the 10 cations into 3 distinct categories. So I have got the top 3 at the top. These are lithium plus, sodium plus, and potassium 1+. Can I just say, by the way, I actually really hate that it's written in this way. What I'm actually going to do is I'm going to delete the actual typed answers, and I'm then going to actually add my own written ones because I like the superscript and I like the extra colors too. So we've got lithium +1. Notice the charge is superscript. If you're asked for the name of this, it is called a lithium ion. Please don't put just lithium, because lithium could be atom or ion, and I need you to recognize that this is all about the ion. We're then going to go to a sodium. Oh, that was an interesting little pen glitch. So we've got Na. Oh, I don't know what's going on there. Let's try again. Na+, otherwise known as a sodium ion. Please remember to include the word ion. And K+. This is the potassium ion. Okay, so these are positive cations, and the only way that you can detect these 3 ions is through what is called a flame test. Now, what I'm going to do is I'm actually going to use this lesson as an opportunity to describe and use the exam questions for how to describe a flame test. I understand that this lesson is not so much about the practical aspect of doing these, but simply the observations. But in this case, it does make sense for me to describe and give you that exam style question. So the exam question here might be describe how to perform. Describe how to perform a flame test. A flame test. Okay, so the bullet points for this are in red. Number 1, use nichrome wire. And that is a key thing, folks. Nichrome wire has a high melting point. Nichrome wire, high melting point and inert. High MPT, melting point, and it is inert, meaning unreactive. We're going to wash my wire, wash wire in concentrated hydrochloric acid, concentrated HCl. I'm then going to pick up solid, and place in blue Bunsen burner flame. And that is how you perform it. What I would probably say is Bunsen burner flame. The last one would probably be record color. Record color. Now, various spin-offs of this question exist, such as why can't you use the luminous flame? That's another very common question. Exam Q. Why not luminous? It's a weird name. I hate that word. Luminous flame, otherwise known as the yellow flame. And the answer for this is that the yellow color will mask. Yellow flame color will mask, cover up. A yellow flame color will mask. You don't have to use the word mask. You can say cover up. Cover up expected flame color, expected flame test color. You'll just see yellow. Yeah, it's a very common question, even at A-level, so it's worthwhile. And by the way, at GCSE, oh my God, super common. It's actually more common at GCSE than it is at A-level, but it's nice to have it. Okay, so let's look at we're going to do all 3 of these in the same instant. So I'm actually going to underline this and say test 1 for cations, for cat ions. And it's nice to do this. Because cats are positive. Because they're positive. Positive. I can't spell positive. That's so funny. Positive, because cats. No. Okay. So test for 1 for cations is a flame test. So we're going to do a flame test. We've now described it. Let's give our colors. And the great thing is what I can now do is blend my 2 groups that I've got here. So I've got cations that I can only test for with a flame test. And then I have cations that I can test for with a flame test and with other tests as well. So I'll put those all here in terms of our results. So let's do our flame test results. So this is really easy. We've done the description. Let's give our results. So lithium 1+. Lithium 1+ will give us a red flame. A red flame. Sodium 1+, Na+, will give me a gorgeous yellow flame. I actually want to write the word flame test, but you get it. I'm going to put it anyway. A red flame test and a yellow flame test. It's just yellow. In reality, they just kind of say, give the color, and you go yellow. Next one is K+. This is a weird one because you can't see any other color, but this one is really bizarre. You have to call this lilac. So this is a lilac flame test, a lilac flame. So we've got our 3 only flame tests. If you're wondering what's happening, by the way, the Bunsen burner, the heat is actually exciting the electrons into an excited state. And when they fall back down to ground state, they emit a photon of a given color. So that's actually what's nice to add this little extra detail in terms of they're different questions, but it's just nice to explain what's happening here. So if you looked at this from like an atom of lithium, yeah, this is lithium 1+ ion, and here are the electrons living in the shells. And what will happen is when we add the heat from the blue Bunsen burner flame, this is adding heat, the electrons become excited and they will jump. So they are, I'm actually going to write here, E- electron excited to a higher energy level. Excited to higher energy level. And this is by the heat from the flame. So it then jumps to a higher energy level. And then what happens is it will then fall back down, fall back to ground state, fall back to ground state. And when it does that, ground stand, nice, Mr. Duncan, ground state. So this is like the heat from the Bunsen burner. And I feel like I want to redraw that now. There you go, heat from blue flame. And falls back to ground state. And when it does that, it will emit a photon. And lithium emits red. So this red, this is a photon that is being emitted, a photon, and that is in the red frequency. So it's just nice to explain to you where it's coming from. Different ions have different configurations, so fall back down differently and emitting different frequencies of light. That's how it works. It's just nice to give you a bit of an insight into how it works. Okay, so we've picked up our 3 only flame tests. We can now add our mixture flame tests as well. So we've got 4 others that we need to remember. The next one is calcium. So calcium 2+ is a orange-red flame test. This is orange-red. Now notice that it has 2 colors in the name, and that is absolutely spot on. These actually have to, this is an orange-red flame. Orange-red. Then we pick up copper. So copper, Cu2+. Copper is another 2 colors. This is blue-green. This is not going well with my blue, and then changed. This is a blue-green flame test. Both colors should be mentioned. Blue-green flame. Next is strontium. So strontium is Sr2+. This is another 2+ ion. And again, two words in the name. This is a crimson red. This is actually a lot brighter than the lithium flame. So we call this a crimson red. Last one, which one's on my list, is barium. So barium, another 2+ ion with 2 things to the name. So barium 2+ is a pale green. So this is a pale green flame test. not the same as it. By the way, when I say very, it is really pale. It's borderline yellow. I have actually seen them call this a yellow, which I absolutely hated, by the way, because it is so pale. It's like a greeny yellow. So you could almost do green yellow. Be interesting to look at a mark scheme and see how long it takes to come up. But guys, those are all of your flame tests that you guys need. You don't need any others. These are the ones that you need and the ones that they expect you to know. And yes, guys, I'm really sorry. You just have to know them. There is no rhyme nor reason to it, but it's nice to see that the top ones, which are the 3 1+s, have one color in the name: red, yellow, and lilac. The 2+s are orange, red, blue, green. By the way, you can say green, blue, or red, orange. It wouldn't make any difference which way around you say it. Crimson red, pale green, sometimes pale yellow. So just letting you know, they don't tend to call the barium 2+ yellow because it then overlaps with the yellow in sodium. So that's kind of why they do what they do, but I've seen places refer to it. So it's just something to keep an eye out for. Okay, so we've actually done the cation testing, which is really nice. So I can tick off now flame tests. Flame tests are done. And you can see that, by the way, I've covered each of the 7 that are here. Now we need to talk about our other tests. So we've done a flame test. Now we need to move on to test number 2. So test number 2 in chemistry for these cations is a test called sodium hydroxide. So it is a sodium hydroxide. For those, and I assume my year 8s have probably left me now. But there's my sodium, some yellow sodium, the flame test being yellow. But it's nice to also show you guys, if you're still here, that this OH here is called a hydroxide. It's actually a negative, by the way. It's nice to show you it in terms of charges. We actually have here Na+ and OH-. If I flame tested sodium hydroxide, I would see yellow. So it's just nice to show you what it's made from. So this is called a sodium hydroxide precipitate test. Sodium hydroxide precipitate test. Now, a precipitate test is when a solid appears in a solution. This is where, if I had planned my YouTube videos and actually, rather than doing them live, if I did these kind of like I pre-recorded them, I'd add in loads of videos of precipitates forming and animations. Oh, I wonder if anybody's, I'm still here. That's so funny. I've got somebody else too. Yo, it'll help me in the test. Yay, Big Ben the Penguin. Nice. I'm glad you're here. I hope it helps. Let's get rid of that because it's actually, no, I don't think it's causing me any problems in terms of my laptop speed. So I'll just keep going. Okay. So as I said, I wanted to show you guys actually what a precipitate test looks like, because they often call this a gelatinous precipitate. So if I go precipitate, I'm actually using YouTube whilst live streaming on YouTube. Like, that is genuinely hilarious. This is what a precipitate test looks like. I don't want any music on this. And I'm just sharing my whole screen. So you've got 2 solutions going in, which are colorless solutions. The next one is a bit cloudy, but they should have filtered it and it would have been clear. When they mix together, we form a solid. So there you go. There's our yellow solid, and that's going to be lead iodide is what's being formed there. And it turns cloudy. This is called a precipitate test. Okay, so the sodium hydroxide test is used for a variety of substances, including all 7 of these. So we can actually say that these ones here can be tested for, got to be careful. This isn't true. Sodium hydroxide, I should have put this in order. Oh, Mr. Duncan, that's interesting. Calcium can be tested for sodium hydroxide. Copper can be tested for sodium hydroxide. Barium can't be, and strontium can't be either. That's interesting. Probably should have thought about that and put it in a nice order so you could have seen these, but meh, whatever. This one can be tested for with iron 2+ sodium hydroxide, iron 3+ sodium hydroxide, and funnily enough, ammonium, even though that requires a separate conversation. So let's have a look at our sodium hydroxide test, and I'm going to put these 4 colors into one separate thing. Okay. So The ions that we need to know for testing for, by the way, this is not an all-inclusive list. Aluminium and zinc can also be done. And I'm just warning you, I'm not trying to be perfect here. I'm trying to just make sure I get the majority of this done. So our sodium hydroxide test, what do we have? We have calcium 2+, we have copper 2+, we have iron 2+, we have iron 3+, and we have, I'm now going to underline this because this is slightly different. We do have the ammonium ion. Yeah, and by the way, notice the change in name. This is the calcium 2+ ion. Notice the name doesn't change. Yeah, but we can test for these with sodium hydroxide. Now what I'm going to do is I'm going to give you the equation followed by the observation. I'm doing a slightly different mixture compared to what I'm used to in the previous videos. The calcium ion will react with the OH- ion. It'll react with two of them to form calcium hydroxide. Now, this is not a transition metal. Notice the Ca2+ is aqueous, the OH- is aqueous, and I now form a solid precipitate of calcium 2, or just calcium hydroxide. And this is a white PPT. And by the way, PPT stands for precipitate. I'm going to write precipitate, and then I'll put underneath it PPT so I don't have to write it again. Cool. Let's look at the next one. Copper 2+ reacts with two OH-. Notice that the number 2 is matching the charge number. Opposites attract. A 2+ will attract two 1-. So it's just nice to see that following over. Both of these are aqueous. Now this one's an interesting one. Now I said to you in the previous lessons, you should never give just one color. What actually we should be saying here is, in calcium's case, let's improve this. It will go from colorless Ca2+ aqueous, and it will become a white PPT, a white precipitate of calcium hydroxide. Yeah. So I'm giving the before and after color. Started off colorless, and then it ended up full white. Really, really white. Went from colorless to white. I'm actually going to do that. Yep, colorless to white. Okay, now copper's a bit more interesting because copper 2+ is a blue solution. It's tempting to actually show you the video of this one because I probably can. So let's see if I can do this one. Aqueous, and I'm going to form copper 2 hydroxide. Notice the formula as well is matching the number of ions. Notice the brackets as well. So this one is now forming a blue precipitate. So the words for this are, it went from a blue solution, aka 2+ aqueous. Aqueous means dissolved in water. And it's going to form a blue precipitate, which is a solid, a blue precipitate of Cu brackets OH. I don't need to write it multiple times because you kind of get it. But it goes from blue to blue, but it does look distinctly different. And actually, I think it's worthwhile me just jumping onto YouTube and showing you what this one actually looks like. I'm not going to do this every time. Don't worry, folks. Really, honestly, let's just do a copper precipitate test. Copper and sodium hydroxide. Let's do that. There you go. It'll take 10 seconds, 25 seconds, guys. This will be interesting. There's the blue solution. It's dissolved. It is not cloudy. The bottle's just dirty. It's a really bad video. That's right. No, he's rubbish. They've done the sodium hydroxide first. Why would you do that, you stupid people? Right, here's your video. She's got a blue solution. There's the blue solution. There's no solid there. And then when she mixes the two together, watch what happens. Watch what happens. It goes cloudy, and we form this jelly-like precipitate. Sometimes referred to as a blue gelatinous precipitate, but you just call it a blue precipitate, which is a solid. So it's nice just to see that in terms of, I'm not trying to do this, like practical lessons are completely different. I have got, I'm still here, meh, whatever. Precipitate, PPT. Vettel's still there watching. Thanks, Vettel. It's nice to see you hanging around. You don't need to, by the way, but you're more than welcome to hang around. I'm hoping this is still running. Okay, so going back to this. So we've got a blue precipitate. Now, iron, notice again, guys, what I'd like you to do is take a pause the video and see if you can write the equations for these two now underneath, because chemistry is about patterns. And using those top two equations, you should be able to construct the next two. Pause the video and then see if you get it right. So unpaused. So this one is going to be two OH minuses, because the OH minus is going to match the 2+ in the charge. And it is going to be aqueous, because sodium hydroxide is aqueous. And I'm going to form Fa, open brackets, OH, close brackets 2. And it's going to be a solid. Let's look at what the color is. This started off as a green solution. This was aqueous. This is a green solution. And it turns into a green precipitate. So this turns into a green PPT. Let's write down the note next door. So we started with a green solution and it became a green precipitate. It turned into a solid PPT. And it's nice then just to add the colors there as well. One of them you can see through, one of them you can't. Okay, and I hope to think that you had to go at the next one, because this one's nice application of chemistry. This one has a +3 on it, which means I've got to react to this with 3 OH minuses, aqueous. Now, iron 3+ aqueous is yellow. So this one's a bit more interesting, because iron 3+ in water is yellow. When it forms the precipitate, it turns brown. Notice the formula. The brackets this time has a 3 outside it. And this is a brown precipitate, a red-brown. It's not red, by the way. It is genuinely red-brown. Red-brown precipitate. I actually just flat out prefer brown, by the way. I hate red-brown, but I have to teach it. So this is yellow solution, yellow sol, going to a brown precipitate, brown PPT, brown stroke red. I like it. So it's nice then just to add our colors on there over there as well, just to see it again. It's just nice to do it. Cool. Okay, so we're seeing all these beautiful colors. Now at this point, our precipitate tests are kind of done. There are others, which are zinc and aluminium, which are both white and colorless in solutions and white precipitates, but I haven't seen them on tests recently, so I'm going to skip that one and just say if you pick these up, go and have a look at some of the YouTube videos and have a look at people doing those tests. I'm not being as complete as perhaps I would usually like to be, but it's just nice to, I don't want to spend too long doing stuff that perhaps aren't going to come up very often. Okay, by the way, just to let you know, Evans, you actually have a whole load more of these at GCSE than there are at A-level. You have chromium 3+, aluminium, and zinc as well to add to this. But don't worry, this is just me covering the A-level stuff. Okay, so we've done all the precipitate tests. We can tick off this guy. We can tick off this guy, and this guy. Okay, so now what we need to do is we've got this ammonium ion sticking out at the bottom. And this is still in the sodium hydroxide test, but this one is slightly different. Ammonium has a 2-step process. So we test for ammonium. So this is kind of a little mini subheading, NH4+. This is called the ammonium ion. I know, rather than ammonia, which is NH3 gas, this is ammonium, NH4+, ammonium ion. Now this one is a 2-stage process. Step 1 for the test of this. Step 1 is to add sodium hydroxide. Add NaOH. Okay, here's the equation for what is happening. The ammonium ion is reacting with the OH minus ion to turn into ammonia gas and water. So this is an interesting test because it's an acid-base reaction. The ammonium is acting as an acid and the OH is acting as a base, and it's forming ammonia gas. In step number 2, we warm it. Step 2 is to warm it. Warm mixture. Now, the reason why we warm it is because the ammonia that we have created will dissolve. The ammonia gas that we've created will dissolve into the water. So we need to get it to come out. What's going to happen is this is going to warm the mixture, and the ammonia gas will escape. Whoops, will escape. Now we can now test for that gas. Step number 3 is we are going to test this, which we did in our previous video on gases, with damp red litmus paper. Damp red litmus paper, and it will turn blue, red to blue, or we could test this with concentrated HCl, and I would get white smoke of ammonium chloride. So we've got this really interesting process of the ammonium ion, because it links in. There was a reason why I did my gas test first, by the way, and this is why. There's no point in doing this lesson without you knowing your gas tests. Okay, so my sodium hydroxide test is done for the ammonium ion, which is great. Now, the big question now is, what other tests are there? So, okay, now this is an interesting one at this stage, folks, because what I'm now going to do is I'm going to link a lot of these together in order to show you that there are some alternative tests. Now, the main one is the carbonate test. So we can then put, this is a carbonate test. This is called the carbonate test. The reagent is sodium carbonate. Reagent is Na2CO3, otherwise known as sodium carbonate. Okay, we can test, and we're going to add this aqueous, meaning in solution, dissolved in water. Okay, this is the test. And what we're going to get is a whole load of precipitates again. And the great thing is, a lot of them match the previous precipitates we've seen. Now, there's a couple here that I need to do. I've suddenly realized I've missed an ion. I've missed silver. So I need to add in an extra one, which is a silver ion, number 11, Ag1+. So easy to miss. I could actually add lead and mercury as well, but I won't bother. Silver's the one we need. So carbonate test. Now here's a fact for you, which is 2+ ions, nota bene, change my color, nota bene, 2+, I don't like it, no, 2+ ions form insoluble carbonates. Okay, now I know that doesn't really mean much. Let me show you what I mean. Let's grab all of our 2+s. Let's go for barium 2+. Barium 2+, which we could flame test and get pale green. If I added to this a carbonate ion of CO3 2-, ought to put that up there, by the way, that's the carbonate ion. Yeah, I will form insoluble barium carbonate, which is white, a white PPT. If you're asking me how I know all my colors, well, if you're not in the transition metal block, you're going to be white. So barium carbonate is white. If we do strontium, Sr2+, I'm going to form strontium carbonate, which, surprise, surprise, is a white solid. Gotta love it. White PPT. We can also do copper 2+. Now, copper 2+ is a transition metal, which means it's going to react to form copper carbonate. And this is the first one with a color. This one is blue-green. It's turquoise. You're not allowed to call it turquoise, but it technically is. You call this blue-green. Copper carbonate, blue-green. Let's try and zoom in. Blue-green precipitate. Blue-green PPT of copper carbonate. Let's go for iron 2 carbonate. Iron 2 carbonate. I love iron 2. All of them are green, by the way. It's boss. I'm going to form iron 2 carbonate, which is a solid, and all iron 2s are green. I love that. All iron 2s are green. Gotta love it. Green PPT. Green precipitate. What are the ones have I got? Have I got anything else? What are the ones have I got? Oh, it's copper done. Calcium done. Strontium done. Barium done. Did I do calcium? No, calcium would also form calcium carbonate, which is we saw in our gas tests. calcium 2 plus will react with CoCO3 to form CaCO3. It's just going to form a white precipitate because it's not transition metal. Gotta love it. So carbonate tests. A bit more unusual than the other tests. We'll see this when we go through papers. Okay, is there anything else I want to do? Yes, the barium test. Okay, now there are some ions that have their very own tests. Their very own tests. The barium 2 plus ion, so barium 2 plus has a very special test. The barium 2 plus ion will react with sulfate ions. So we can test for the barium ion with a sulfate. Test for barium 2 plus is a sulfate ion. Test for barium 2 plus is a sulfate ion. SO4 2 minus. The question is, where do you get that from? Reagent. Sulfuric acid would be good. Sulfuric acid in aqueous dissociates to give us H2SO4. You put it into water and it forms this, SO4 2 minus. Yay! So now I can just add sulfuric acid to something that I think contains barium 2 plus, and I'm going to say barium sulfate. Let's have a look. Ba2 plus SO4 2 minus goes to barium sulfate. White solid. Now, this is a special test, by the way, white PPT. This is a special test because barium sulfate is so insoluble, you can actually drink it. We use it for x-rays. This white solid, this is in a group 2 lesson. This is used for x-rays. You drink it, and when you drink it, it makes your stomach light up like a Christmas tree on an x-ray. Used for x-rays on people. It's called a barium meal, and it's non-toxic because it's insoluble. Right, let's check my thing. I think actually we've got a whole load of these, which are great. It all works out. I think we're done. Cations. I think we're done. Sodium hydroxide, flame tests, and then the carbonate and the barium with the sulfate ion. We're done, folks. That was a nice, easy. And we've been doing all of the equations to go with it. It's awesome. Nailed it. That was really short. I'm done. Amazing. Can't wait to get to the papers so we can start putting all this stuff together. Let's have a look. Hannah, hello. I am Hannah and a very big fan. Hi, Hannah. Hi, Bobotics. Thank you. I'm going to get rid of my thing. There we go. Way! I'll stop sharing my screen. Hi, Hannah. Thanks for coming along. Oh, I'm so glad that you're a big fan. I'm a big fan of yours too. All right, Mr. Duncan. I'm go now. I might come back if I have a good one. If I can have a good one. Don't know quite what that means, Vettel, but nice. I used to watch you for A-levels, and now I'm about to graduate uni. Thank you for doing what you do, and you helped me greatly during those times, even though I haven't seen Chem since then. Oh, WA, thank you so much for that. It is so nice for you to say that on my channel. As a teacher, you know, I'm doing this on the weekend. I've actually just finished for my half-term holiday, and I'm doing this because I know that my year 12s will really appreciate them. So I really appreciate that. Thank you very much. And I hope you're doing really well in your university degree. And I wish you the best of luck. Guys, thank you so much for coming along. I've got two more of this sequence to go. I'm going to do anions next, but I think today I'm going to let this go. Been doing chemistry for the last 3 hours, but I'll pick it up on Monday and finish off our anions. And then I'm going to have a look at some A-level papers and we'll go all the way through it. It's tough. It's such a nice thing to bring everything together. Guys, have a nice rest of your Saturday. I'll see you soon. Take care, guys. Good luck.